In the next, let us consider the the training algorithm of our first data model, the perceptron. To train or to learn the data model is to adjust its parameters according to data. Therefore, after the training, all the information embodied by the observed dataset has now been encoded in the model parameters. We consider a few aspects when it comes to training. The first question we want to answer is when to train. So, if we recall the learning diagram, at the last, the goal of the training is to deliver some particular data model. You don't want to change after you have delivered the model. So we have been now we are now looking at the goal at the starting point, where to stop. So it is necessary to adjust the parameters according to the data. When the prediction of the model at some data point does not agree with the given label or the given target value at that point. When it comes to perception, that is, the combination of the weights and the data attributes, you get the pair products and sum them up, then the sum of this combination is not the same as that of the target value. Well, we use positive or negative one to represent the two classes in this context. Um, so then what it is a step size target of a training step. What to do? We want to adjust our parameters so that after this adjustment, the combination of the weights and the data attributes moves toward the desired label, either it to be positive one or negative one. Then how? The inspiration is from the fact that the excuse me, the sum of the square of the attributes must be no less than 0. So given this fact, a clever idea is, well, if you want to have the sum of the products move to the direction of some either positive or negative value, then if you want to increase it, you might as well just adjust W in the same of the same as the attribute itself. Therefore, in this representation, please notice that to to emphasize this is a combination, pairwise combination, I use this inner product symbol to represent uh, this. They are the same, exactly same. I use an arrow here to represent that W is a vector has multiple values, and use an arrow here to represent X is a vector as well. And the inner product represents you take the pairwise product between two vectors and take the sum. We want the inner product of these two vectors move towards the value of y. Then we cannot do anything about x because this is an observed data sample, but we can adjust w. We adjust w towards the direction of x multiplied by the desired value of y. So if we want to increase the inner product, then y will be 1 plus 1. The increment is x itself. Therefore, the inner product will be x by x itself. It must be greater than 0. And remember that we want to move towards the direction of +1. On the other hand, if you want to move to the direction of -1, this equation will let you to increase w towards the direction of negative x. So basically, it would be negative x square, x0 square, and negative x1 square. When we collect those values, the sum must be less than 0.